One of the ideas that we should get out of a physics class on mechanics is the idea of, if you know the current state of motion of an object, where is it going to be a small time in the future? That's the idea of predicting the motion of an object, which you can watch in another one of the videos here, but we'll look a little more specifically here. Here we have a ball here which is flying through the air, and there's an arrow sticking out of it. So the claim is that under what conditions would you be able to predict where this ball is going to be? So say, for instance, I told you this arrow here was a force vector. It turns out the force vector won't tell you where the object is going to be a small time in the future. It's very difficult to predict with this force vector if the ball is actually moving in that direction or not, because it could be moving, say, this way. This is just some child with a rope pulling it that way. The ball is moving that way, but it's getting pulled that way. It turns out if it's getting pulled this way, then it would probably be over here a small time in the future. So you have to be a bit careful with that. Well, say it wasn't a force vector. Say then it was a position vector. The position vector also doesn't tell you where the object is going to be a small time in the future. We know the object's right here, so this drawing is actually kind of silly. The object is right here. There's no reason to draw a position vector on the object itself, unless you're, say, referencing another object. So we'll take that one out. Well, one of the other variables we know is acceleration. Turns out acceleration also will not tell you where the object is going to be a small time in the future, because once again, the ball could actually be moving this way. Say a velocity vector could be sticking out going that way. And just because the acceleration vector is up there doesn't mean the ball will be following that acceleration vector. Now, it might eventually, but not in the small time in the future. So it turns out the vector that we're most concerned with or most happy with in terms of understanding motion is the v vector, the velocity vector. This is the vector that will tell us a small time in the future where the object is going to be. So for instance, this object here, since it's moving sort of up and to the right like this, will probably be up and to the right a small time in the future. And I'm talking about a delta t in the future here, which is like really small. That's as hard as we can try to predict, push our predictions here, that, likely that's where it'll be based on the v vector, just sort of looking at it. We don't have all the information, but that wouldn't be a bad guess. So one of the things that we're concerned about, though, okay, so fine, we have an object with a v vector, and it's going to be moving up and to the right like this. One of the things we'd like to know how to do is, well, can we change that v vector at all? Like, is it possible to make the v vector point the other way, or go further up, or further down, or just expand the direction it's going? So in other words, one of the big questions for physics and understanding what we're doing here is, how is it that you change a v vector? The reason why, again, it's the v vector is because if you change the v vector, you will change the direction the object travels in. You can change it from moving up and to the right to some other direction, down, up, whatever. So we are focused on changing the v vector. Turns out the only theory we have at this level for changing a v vector is the equation that says that v is equal to v naught plus a times delta t. So if we wanted to change that v vector, and suppose the v vector, the current position of the v vector is just as we've drawn it up here, so I'll go ahead and recast this v vector as v naught to be the current velocity vector, or the initial velocity vector where the object is right now. So here that is. If I wanted to change this to some new v vector, well, what I have to do, I have to apply an acceleration to the ball, and I have to let a little time pass. So there's two things I have to do before that v vector is going to change. An acceleration over time. And so that's a big sort of part of this class here, and the answer to this question here about how do you change a v vector. Well, you change v with an a vector and a little time, delta t. Those two things are required to change a v vector. So if I go back to the ball now, if I wanted to change this v vector, I could say apply some sort of acceleration on it, maybe down like that, and I'll say that a right there, there's my a vector. And now what I can do is say, okay, well, the theory tells me that this initial velocity vector v naught can be morphed into a new vector v with an acceleration allowing a little time to pass. And so with this acceleration, if I let a little time to pass, it would be correct to say then, well, here's the ball once again, and as long as that v vector is pointing, that a vector is pointing down on it like that, where's the velocity vector going to be next? Well, since a is pulling it down and I let a little time pass, this velocity vector will just get pulled down a little bit. So maybe in the drawing up there, it's pointing straight up like that, but given this a vector and a little time going by, the v vector is going to be maybe sort of down like this after a little time goes by. So see, I've changed the v vector from that first position right there to that second position right there by applying that acceleration to it and letting a little time go by. So two things are required then to change the direction of travel of an object. You have to apply an acceleration and you have to let a little bit of time go by. And so it's this interaction which can be very important to us, And hoping you just remember that it's really that velocity vector which is the one that allows you sort of to look at an object and go, I can get a feeling of where this object is going to be next, because that velocity vector is really the clue to that. That's the direction it's traveling in.